Everyone, welcome to the session on energy engineering. So let us continue with the topics which are related to the module number 1, that is thermal energy combustion systems or conversion systems. So here in this class we will try to discuss about the coal burning methods, and then what are the classification of this coal burning methods, as well as we will try to discuss the different types of coal burning methods. So coming to this classification of coal burning methods, okay, so we have the solid fuel burning. Okay, so coal is an example of a solid fuel. So solid fuel burning can be done like in these three ways. Okay, these are the main ways, okay, are the methods in which that a solid fuel, that is coal, can be burned. The first one is hand fired, and then the second one is stoker fired, S-T-O-K-E-R, stoker fired, and third one is pulverized fuel fired. Okay, so the first one is hand fired, the stoker fired, and then pulverized fuel, okay, fired. And then again this stoker fired, the method of coal handling, okay, or coal burning method can be again classified as overfeed stoker and then underfeed stoker. And overfeed stoker, okay, where we take this coal over this stoker, okay, so again classified as a chain grate. Here we have basically two sprockets, and then over which a endless chain is mounted, over which the coal is like a moved, okay, into the furnace, and then while moving, okay, the burning of this or combustion of this coal takes place, okay, with the help of this like in the presence of air, okay, or oxygen. So again we have a traveling grate, which like there is no much difference between chain grate and then the traveling grate. And then we have a spreader type, okay, where we have a spreader, okay, which helps to distribute this fuel, that is solid fuel, the coal, okay, over this grate, okay, where we are going to burn this coal, okay, uniformly. Okay, that is why the function of spreader is to distribute that coal, okay, uniformly over the grate, and then the proper combustion should takes place. Okay, so that is about like one more type under this overfeed, that is a spreader type of a stoker. And then we have again pulverized fuel fired. Okay, so here it is there are again two methods in which we can burn this coal. Okay, so one is unit system and then the central system. Okay, so those are the two methods. And then again underfeed stoker, so there are again two methods, one is a single retort and multi retort. Okay, so this is the brief classification, okay, so of okay how this coal burning methods, okay, so it takes place. Okay, so mainly we have hand fired, stoker fired, and pulverized fired. Again stoker is overfeed stoker, if you take the coal above the stoker or the below the stoker, and then underfeed stoker. Okay, and then overfeed stokers can be like again classified as a chain grate, traveling grate, and spreader type. Okay, and underfeed stokers we have two types, one is single retort and multi retort. And then pulverized fuel fired, you have like a unit system and then the central system. This is a broad classification of, okay, the coal burning methods. Okay, so let us move on to the next like a topic. Okay, we will discuss some of these important methods of coal burning. The first one we will take is, okay, so traveling grate stoker, or which is also called as a chain grate stoker. Okay, so which will be classified under overfeed stoker. Okay, so if you see this classification, so here we have a solid burning stoker fired, and then overfeed stoker, under which we have a chain grate or a traveling grate. Okay, so that is what we are discussing here. Okay, so this is a traveling grate stoker or a chain grate stoker. Okay, so basically coming to this, this is a sketch for the which represents this traveling grade stoker or the chain grade stoker. So let us see what are the different components we have, and then later on we will see the how does it work, or the working principle of a traveling grade or a chain grade stoker. Okay, so basically we have this coal hopper, and then the second one is, okay, we have this a chain, that is endless chain, which is mounted over this sprockets. Okay, so sprocket is a wheel which has a teeth around which, okay, for example, if you have a bicycle, okay, for the pedal there is a one front sprocket, at the back also we have one more sprocket. Okay, so it is a wheel which is provided with the teeth and the circumference over which a chain can be mounted. Okay, that helps to a transmission of the power. Okay, so here in the similar fashion we have a endless chain is mounted on a two sprockets. One is a front sprocket wheel and then the rear sprocket wheel. Okay, so these are the two sprockets we have. Okay, so and then we have a primary air ports. Okay, so the air inlets or air ports are necessary for the combustion of this fuel, that is coal. Okay, so we have the primary air ports here. Okay, and then also air can also be supplied through the one more port, that is called as the secondary ports. Okay, so that is mounted at the top of this furnace. Okay, so the furnace where the combustion takes place. Okay, so here we take the coal inside, and this is a place where the combustion is taking place. That is why this whole region is called as a furnace. Okay, so the idea behind this thermal energy conversion systems is we use this, the heat which is released by burning this fossil fuels, for example the coal here, and then we use that for generation of the steam, for example. Okay, so where this generation of the steams takes place, the water is converted into steam, so that is in the boiler. Okay, how does it takes place? The flue gases, okay, which are released after this combustion of this coal, okay, and passes over this boiler tubes. Okay, the heat transfer takes place between this flue gases and then the water or the medium. Okay, water or the liquid which is flowing inside this boiler tubes. Okay, that heat transfer, okay, so will helps to produce the steam. Okay, so after this passing over the boilers, okay, that flue gases can go at this point here. So normally through the chimney is a component, okay, which is helps to throw out the like a worked out gases, okay, to the atmosphere. Okay, this is the exhaust to the chimney. Okay, so and then we have one more opening here. So this is after burning, the coal turns into ash. That ash can be, okay, collected at this point. Okay, so this is about the various components of this chain grade stoker or a chain traveling gate stoker. Okay, so here coming to working principle of this one, the coal hopper, okay, which is gravity type of an hopper. Okay, so where the coal moves inside this hopper, okay, with the help of a gravity. The coal is taken inside this hopper here, and then we have this adjustable gate. Okay, the function of this adjustable gate is to control the depth of this coal or the fuel on this grater. Okay, if it is in a totally closed position, there is no flow of this coal over this grate here. Okay, chain grate. Okay, so like by lifting this gate, okay, or adjusting this gate, you can control the depth of this coal over this bed here. Okay, so and then once this coal hopper, okay, so the coal is taken from the hopper, okay, through the adjustable gates, it falls onto this a chain here. Okay, this is a endless chain which is mounted on a two sprockets. Okay, these sprockets are rotating. Okay, when these sprockets are rotating, this chain will also be rotating. Whatever the coal which falls on this one, so also moving. Okay, so along with this chain here. Okay, so and then along with this we have this a primary air ports and secondary air ports through which we supply the air. In the presence of oxygen, the combustion takes place. So inside this furnace, whatever these flue gases, which are the very high temperature, which are passed on to the boiler, where the water is converted into the steam, and then that after this like a transfer of heat, the flue gases are exhaust okay, to the chimney, okay. And then after burning, the coal, which is the ash is formed, that ash is collected in this pit here, okay, that is called as the ash pit, okay. So this is like a construction and working principle of a chain grate stoker, okay. So let us see some of these advantages of this like a chain grate stoker, okay, or the traveling gate stoker. The first one is, which is very simple in construction, and then the cost wise, the initial and then the maintenance cost is very less, okay. So for this one, and then this is a self cleaning type of a mechanism, okay. Since this chain is moving, okay, it cleans by itself, okay. So there is no like a coal is deposited on the chain because it is continuously moving, okay. So it is self cleaning type of a chain grate or a traveling gate, okay. So and then one of the disadvantage is, okay, the air which is taken from secondary as well as a primary inlet ports, okay, cannot be preheated behind 180 degrees centigrade, okay. So if you want to preheat the air, it should be less than 180 degrees centigrade. That is one of the disadvantage of, okay, so this overfeed stoker or a traveling gate stoker. So this is one type. Next type we will see, okay. In the solid fuel, we have a stoker fire. One is overfeed and is underfeed, okay. Under the overfead, we have discussed this chain grate or traveling grate stoker. We will next see what is the construction and working principle of this spreader type of a stoker, okay. So here this sketch shows the schematic representation of this spreader stoker, which is also called as a sprinkler stoker, okay. Why this name spreader stoker, okay. So spreader means whatever the coal which we taken from this hopper, okay, the solid fuel is spread, okay, so over this grate uniformly, okay. So with the help of this spreader stoker or with the help of this sprinkler stoker, so we spread this coal uniformly over the grate, okay. That is why it is called as a spreader stoker, okay. So coming to this in this case, okay, the fuel burns, the fuel is coal here, partly in the air and then partly on the bed, okay. So when this is thrown here, it burns partly in the air, okay, as well as it burns partly on the fuel bed also, okay. So and also we have this different components, okay. One is this coal hopper, and then we have a feeder here, and then we have a spreader. That is why we have this name spreader stoker, okay. And along with this, we have this like a fuel bed, and then the air like a ports for the admitting the air or the oxygen, okay, through this one, and then we have this furnace as well, okay. So here the coal is taken from this coal hopper, okay. Hopper is like it acts as an inlet, okay, to take this coal in a lump form, okay. So and then it passes on this feeder. What if this feeder is? It is a cylindrical like a rotating element. Upon this circumference of this feeder, a small teats are provided, okay. These are the small teats are provided on circumferential, okay, circumference of this drum, okay, or the feeder, okay. So which is rotating at relatively low speed, okay. So it is rotating relatively at low speed. Whatever this coal come from this hopper, okay, it falls on this feeder, and then this the coal is supplied onto the spreader. What is the function of the spreader, okay, I'm sorry, feeder, okay. So what does it do is, okay, the main function of this like a feeder is it feeds the coal, that is the fuel, okay, continuously to the spreader. Okay, the name itself suggests, okay, it continuously feeds, okay, the feeder. So it continuously feeds this coal to the spreader. Okay. So next, when this coal which is taken into the hopper and then which falls onto this like a feeder, which feeds continuously the coal to the spreader. In the spreader also we have, which is like a rapidly rotating shaft on which multiple teeths are mounted. Okay, so spreader is a we have on the circumference of the spreader we have a multiple teeths which is rapidly rotating, whereas feeder is at a low speed, whereas spreader is rotating at a higher speed. Okay, so when this rotating at a higher speed, whatever this coal coming from this hopper and then passing onto the feeder and continuously fed onto the spreader. So while rotating, the teeths, okay, so kind of spread this coal, okay, throw away this coal, okay, uniformly over this fuel bed. Okay, so uniformly over this fuel bed. Okay, so while it is spreading uniformly over this fuel bed, part of the coal combustion takes place in the air itself. Okay, this is when it is spreading in this air, okay, itself the combustion takes place, and then whatever the unburned coal which falls on the fuel bed, which is burnt, okay, on the fuel bed. For the combustion, of course, we need oxygen or the air that is taken from these ports which are provided at the bottom. Okay, so this is how this spreader type of a stoker works, because we have a component which is called as which is called as a spreader, which helps to spread this coal or the fuel uniformly over this fuel bed. That is why it is called as a spreader stoker. Okay, so this is about the construction and working of a spreader stoker or a sprinkler stoker. Okay, so next we will discuss other types of stokers. After discussing about the underfeed and overfeed stokers, let us discuss about the pulverized fuel handling. Okay, so in the pulverized fuel handling, so we have basically, they are classified as two types. The one is the unit system, or it is also called as a direct system, and the second one is the central system, or it is also called as a bin system. Okay, so let us discuss with the help of a schematic diagram or the flow chart how does this unit system and like a central or bin system work. So coming to this unit system, so this is how the like a schematic representation of the unit system looks like. So what are the different components we have here is, okay, so basically we have this raw coal bunker, and then we have a feeder, and then we have a pulverizing mill, so and we have this burner, and then this is part is called as a furnace. Okay, so these are the important components. Okay, so feeder, raw coal bunker, pulverizing mill, okay, and burner, and then the furnace. Okay, so basically we pulverize the coal, okay, which is solid coal, which is in the lump form. So and then it is pulverized in the pulverizing mill, and then it is transported to the burner, okay, where the burner like the coal mixes with oxygen, and then the burning takes place inside the furnace. Okay, so like coming back to the what is the function of each individual parts. Okay, so here the raw coal bunker, okay, which acts as an input point, okay, for this pulverizing mill or the unit system or direct system mill. So where the coal in the lump form is taken into this a bunker. Bunker is kind of a storage bin, okay, or we can take it as a hopper. So and then it is fed to the feeder. Okay, so the function of feeder is to like feed the lump form coal, okay, at the required rate. Okay, so as and when the demand, based on the furnace requirements or the load on the system, like load on the system. Okay, so it has to supply that amount of coal. So feeder, the main function is to it supply the coal, and then we have this hot air input to the feeder as well. Okay, why we need this hot air is, okay, so if you like, in order to remove the moisture content in the lump form coal, okay, if you remove the moisture content in the fuel, okay, it increases the like efficiency of that fuel. Okay, so that in order to remove that moisture, so we can supply this hot air to this feeder. Okay, so from the feeder, the lump coal, okay, so is transported to the pulverizing mill, okay, which is normally attached with this fan. So what happens inside the pulverizing mill is the pulverization of the coal takes place. Lump form of a coal is crushed into the, or it is crushed into a fine form, okay, powdered form of a coal. So that fineness, okay, how much fineness we need, okay, so that can be controlled inside this pulverizing mill. Okay, so basically a solid form or lump form of a coal is converted into a fine coal, okay, or the fuel. So that is next transported to the burner. So here at this point we admit the primary air. Okay, so the function of primary air is, okay, it is to transport the coal from the pulverizing mill up to the burner. Okay, it carries that air, the primary air carries the coal, fine form of the coal particles until the burner. Okay, so and then at this point a secondary air is also admitted. The secondary air helps in burning of the coal. Okay, so because we need oxygen for the burning, so that secondary air, okay, so helps for the burning of the coal. Okay, so after this coal, primary air and then the secondary air, okay, so enters this burner, okay, where the ignition takes place. Okay, and then that is inside the burner, that fuel, that is coal, which is in pulverized form, okay, starts to burn. Okay, that can be used, okay, in the boiler, okay, for example. Okay, so this is how the unit system or the direct system works. Okay, basically we take the lump form, okay, so of the coal in the raw coal bunker, and then it is fed to the feeder, and then hot air is also admitted into the feeder in order to remove any moisture content, and then that dried lump coal is now enters into the pulverizing mill. Inside this pulverizing mill, the lump form of the coal is converted into the pulverized coal, that is a bigger size coal fuel, okay, is converted into a fine, okay, a coal particles. Okay, so that is taken to the burner with the help of a primary air. That primary air acts as a transporter, and then in the secondary air is admitted to the burner, and then the coal and primary air also coming to this point here, and then the combustion takes place inside this furnace. Okay, so that heat is used to for the to heat up the air inside this boiler. Okay, so this is about the schematic representation, construction, components and working principle of unit system or direct system. Now let us discuss some of the advantages and disadvantages of this unit system. So one of the advantage is it is simple layout and easy operation. Okay, it is very simple in construction, and the operation difficulties are less. Okay, so it is very easy to operate and cheaper than the central system. So because number of components involved are less, okay, so economically it is feasible, and less space requirement because of less number of components. Okay, it doesn't need much space. Okay, so and less maintenance also, so maintenance is also less. Okay, that is one more advantage of this unit system, okay, or direct system. So next, what are some of the disadvantages are, okay, variable load mills are not suitable. Okay, if the load, okay, on the furnace, okay, is varying, okay, so then this system is not suitable. Okay, so because we have a like a single bin here, okay, so that is raw coal bunker, and then if the loads are varying, it may not like the supply of the coal or pulverized coal might not reach the demand, okay, at the output. Okay, so that is why for a variable load mills are not suitable, and it is less flexible. Okay, for the same reason, okay. So you can't operate for the varying loads, okay. That is one of the disadvantage of this, like a unit system or a direct system. Next, the second type of pulverized fuel handling is central system, or it is also called as a bin system, okay. Let us try to understand what is the construction and working of this central system or bin system. So this sketch shows, okay, the construction of this, okay, or the schematic representation of this central system or the bin system, okay. So what are the different components are involved? We have a raw coal bunker, and then we have a like a dryer, and then fan is provided with a vent, and then hot air for the coal drying is admitted here. And then we have a mill, okay, that is a pulverizing mill, where this lump form, okay, of the coal is crushed into a fine form, okay. So that is a pulverized coal we call. So then that is taken into the cyclone separator, okay. So and then we have a conveyor, okay, that will helps to transport the coal, okay, from the cyclone separator to the pulverized coal bunker. And then here we have one more bunker, okay. That is the difference between unit system and the bin system, okay. Here we can store that like a pulverized coal, okay, in certain quantity, okay. So and then that is have a like feeder, and primary air fan is also provided here, and then we have a burner, and then this is a furnace point, okay. These are the various components of this, okay. Let us try to understand what are the functions of all these components here, okay. So raw coal bunker, of course, it is a starting point of this bin system, where it acts as a hopper or the storage at the input, okay. So where the lump coal is taken into this hopper or the raw coal bunker, and then it enters this dryer, okay. The function of the dryer is to take out the moisture in the like a coal, okay, so which is coming from the raw coal bunker. So hot air for coal drying. So obviously in order to dry the coal, okay, or take out the moisture, we need a hot air that is admitted at this point here. And then we have this mill, okay, the pulverizing mill, as I explained before. The function is to crush the coal, lump form of the coal, into the fine powdered form of the coal, okay. So we are basically crushing that. So that is called as a pulverizing mill. And then we have this exhaust fan, and then cyclone separator. It separates the fine coal, or a coal in dust form or a pulverized form is separated from the air, and then only that pulverized coal enters onto the conveyor here. So where this function of the conveyor is to transport the coal from the cyclone separator to the pulverized coal bunker, okay. So here the pulverized coal bunker, the function is to store the pulverized coal, okay. It has attached with a feeder. The function of the feeder is to admit the coal into the burner at the required rate, okay, based on the demand. And then we have a burner where the burning of the coal with the oxygen or the air takes place, and then furnace, okay. So from the furnace, okay, the flue gases that can be used to heat up the water inside the boiler, for example. So this is the components and their functions. Let us look at the working principle of this one, okay. So here the raw coal bunker, the coal is taken, it also has a certain capacity to store that the coal which is taken in the lump form, and then it is transported to the dryer. As the name itself says, dryer is dries the coal or takes out the moisture from the like a lump form of a coal. To take out the moisture, we need to admit the hot air from the coal drying, okay. The hot air is admitted to the dryer here, okay. So that dried coal, lumped form coal, is enters into the mill, that is pulverizing mill, where inside this mill the lump form of the coal is crushed into the fine form of the coal or pulverized coal. So then it is through the exhaust fan, okay, it is transported to the cyclone separator. Cyclone separator, it separates, okay, air, okay, from this like fine form of the coal or powder form of the coal, okay, or the pulverized coal. That separated air again return back to this mill air, okay. Again it is admitted back into the okay, pulverizing mill. Okay, whatever that powdered form of the coal or the fuel or pulverized coal we have, that falls onto this conveyor. This conveyor, okay, transports that fine coal or pulverized coal to this pulverized coal bunker. The pulverized coal bunker stores a certain amount of the coal inside this one, inside the bunker. So here it is attached with the feeder. Feeder helps to feed this like a pulverized coal at the required rate, and then that is admitted to the burner, okay, where secondary air is also admitted, okay, which helps for the burning of the coal, and then the inside the furnace, okay, that burning of the coal or the fuel takes place. Okay, this is about the construction and working principle of this central or bin system. So how this central or bin system is different from this unit system is that, okay, we have a central bin, okay, so this is pulverized coal bunker, we didn't see it there, okay, so whereas here we have this pulverized coal bunker which stores pulverized coal in certain quantity. So what is our use of that is, okay, so when you have this certain storage, okay, so if the load is varying at this a furnace, okay, so sometimes you need a less coal which is entering into the burner, sometimes load is more and then you need more coal, okay, so entering into the burner, okay, so that fluctuations in the load, okay, or fluctuations in the feeding can be taken care, okay, by this because we are storing certain amount of like a fuel or the coal, pulverized coal inside this bunker. So any fluctuations in the output can be adjusted, okay, since we have this backup kind of like in the form of a storage bunker, okay. So and then feeder which helps to feed at a required rate, okay, based on the demand of this furnace, okay, so we can feed that coal, okay. So after this, let us discuss some of the advantages and disadvantages of this system, that is bin system or a centralized system. Some of the advantages is good control over the coal fineness, okay. As I said before, what we are doing here, we have a lump form or a bigger sized coal which is coarse size, that is converted into the pulverized coal. Pulverized coal is a fine, okay, form of the coal. So that fineness, the control over the fineness, okay, sometimes you need very fine coal particles, okay, sometimes in some other applications we might need very little bit larger sized coal particles, okay. That control over this coal fineness, okay, is very good in this case. So and then large storage, continuous fuel supply, okay, since as I said before, since we have a central bin, okay, or it is called as a pulverized coal bunker, so that stores a certain quantity of this pulverized coal, okay, so that helps in continuous fuel supply, okay, there is no intermittent fuel supply. So since we have a storage, that continuously the fuel will be taken into the burner. That is one more advantage of this central or a bin system. And then mill works at constant load, okay, so this is one more advantage, the pulverized mill which will work at a constant load. Some of the disadvantages are dryers are necessary because in order to take out this moisture, okay, since we have handling a relatively larger quantity of this coal or the fuel, we need dryers, okay, and then since we are storing that pulverized coal in the coal bunkers, okay, since we are handling a relatively larger quantity of the fuel, so we need like there is a risk of fire hazards, that is one more disadvantage of this. And higher power consumption, of course the number of components that are involved in this like a central or bin system are more, okay, so obviously when the number of components are more, okay, so in order to supply the electricity, so we need more power, okay, so power consumption in this case is more, okay. So this is about the two methods, okay, that is pulverized fuel handling, okay, how do you handle this fine coal, okay, or the pulverized coal, okay. So with the help of two methods, that is unit system or a direct system, and one more is that is central or a bin system, okay. These two things we have discussed, okay. So thank you so much.